In this video, we're going to review how to run a correlation analysis in SPSS, as well as how to graph scatter plots in SPSS. So the description of our data are that we are interested in seeing how hygiene is maintained in a random sample of people who decided to get camping passes for all 3 days of EDC Las Vegas. Woo! Okay, so you use a valid method to assess hygiene each day. We don't really know specifically what that is, but it is valid. And then we get hygiene scores from our sample that are on a continuous scale from 0 to 4. So 0 meaning they had really bad hygiene, they smell bad. 4 being they have great hygiene and they smell like they're fresh out of a shower. Okay. So in our practice 2 data spreadsheet, we have our data, which I will show you in a second. We're going to run a linear bivariate correlation for each day of the festival for all festival goers. We're then going to run a correlation analysis using a split file and dividing our participants based on their gender. And then there's 3 different ways that we can graph relationships. If we're looking at all of the data not divided by a nominal independent variable, that's the first graph we're going to make. Then we're going to make one where we show males and females on the same graph but separated, so that would kind of be our split file function. And then we could also use the split file function to plot our males and females for a certain relationship on different graphs. So I'll show you how to do those. If at any point you're like, oh my god, where is all this information coming from? Just look back at the instruction sheet. I won't come back to it just because I think it's easier to stay between the spreadsheet and SPSS. So these are the data we are working with. Our legend for our sex variables, 0s represent males, 1s represent females, so that's in this column here. The ticket number is just in reference to the person or the participant, so we're de-identifying people by assigning them a number value, but these aren't actually a part of our data that we're analyzing. Then we have hygiene for day 1, day 2, and day 3. All of these values are on a continuous scale from 0 to 4. Again, 0 meaning they have poor hygiene, 4 meaning they had great hygiene. What we could do is copy our data. We'll move over to a blank data sheet or data set in SPSS, and then we can paste with our variable names. Then we need to go into variable view so that we can assign values to our sex variable. So I'll have a value of 0 representing males and a value of 1 representing females. We need to change that measure to a nominal variable since it's categorical in nature. And then the scale variables that we have for our hygiene, we're going to say that they are scale data. Okay. Some of you might be thinking like, oh, it's an ordinal value. However, yes, it is on a ranked scale, but we know that it's a continuous variable, and with ordinal variable, there has to be a distinct difference or a distinct distance between different scale points. And typically when we have those scale points, we don't know what we know there's a specific ranking order, but we don't necessarily know what the value difference is between those scale numbers. So if we had first place versus second place in a race, that is an ordinal type variable because there is a specific ranking in which the variables are listed, but you wouldn't necessarily know what the time difference was between first place and second place. It could be 1 minute, it could be 1 second. So that's why these hygiene scale values are considered ratio data in this particular instance. We can go back to our data view to run our analysis. And then we go to Analyze, Correlate, Bivariate. The first relationship we're interested in looking at is the correlation between all 3 days of the festival for hygiene, not separating anybody by their sex. So all we need to do is highlight our 3 days of our festival and insert them into the variable box. The only thing from there that you're making sure is shown is that you're calculating a Pearson correlation coefficient with a two-tailed test of significance. So two-tailed would just say, is there a significant relationship or is there not? We're not specifying if there's a positive or a negative relationship, which is what would be the case if you used a one-tailed test of significance. So make sure two-tailed is checked. That should be the default. Then you can make sure that significant correlations are flagged. So this just makes sure that there's a little asterisk that is put next to p-values that are less than 0.05. If you want to, you can click Show the Lower Triangle Only. So this would be aligned with what we did in our Excel calculations in Practice 1. If you don't have to check this if you want to see how the R values are redundant in the upper half, but sometimes I think it can be a little bit overwhelming because you not only have an R value, but you also have a P value as well as your N, which is your sample size. And all of those things are going to be included in your output. So I personally like to show only the lower triangle. For the diagonal, that's just referring to the diagonal of 1 values or perfect correlation. So you can choose to show that or not. Pretty much past that, we don't really mess with any of the other formatting tools in the test setup. So from here, we can click OK. Then we get a nice output that looks something like this. So across the diagonal, you can see between hygiene day 1 and hygiene day 1, we would have a perfect correlation of 1. And what they've done in SPSS is they've put little dashes to indicate that these perfect correlations are not to be included in your interpretation of your results, just because it's the same variable being plotted against itself. In this, though, we can see the correlation coefficient for the relationship between hygiene day 1 and day 2. So this is R, and this would represent a moderate correlation based on the value that we've got, specifically a positive moderate relationship, meaning that as hygiene values increase for day 1, they also increase for day 2. So the stinkier you are on day 1, the stinkier you are on day 2. The sig row in this table is representing the p-value for this relationship. So it's just telling us, is the relationship significant or not? Since we have a p-value less than 0.05, a 95% level of confidence is the default for all analyses in SPSS. So when we're evaluating this p-value, it is significant because it's less than the alpha we started out with. So if p is less than 0.001, that indicates this is a significant relationship. And we could do a similar analysis for each of the other relationships that are listed in this table. The next thing we are going to do is use a split file to do a correlation analysis based on gender. So to get to our split file, we can go to Data, Split File, compare groups based on sex, click OK. you can see at the bottom, it should indicate somewhere, oh, it's in my data view, but it should indicate in the bottom right hand corner of your data view that your variables are now split by sex. We can then do the exact same bivariate process for all 3 days of the festival. Your settings from your previous analysis should be saved, so you can just press OK. And I'm going to change this for all subjects. Whoops. All subjects. This one's going to be split by sex. And then we could see in our correlation matrix that males' relationships have been indicated here. Females' relationships have been indicated here. Okay. N is representing the sample size for that particular category of our nominal variable. So there are 56 males total in our sample and 67 females total in our sample. Similarly to our first correlation matrix, we get a Pearson correlation coefficient and then a p-value to represent if that relationship is significant or not. The next thing we're going to do is create our scatter plots. So I'm going to go in the order that they are listed in the instructions. So the first graph we're making is looking at the relationship between day 1 and day 2 for all of our subjects. To do this, the first thing I need to do is turn off split file. And then we're going to go to Graphs and Chart Builder. Choose Scatter Dot, and then the first scatter plot option is what you'll drag into your builder area. We then can say Hygiene Day 1 goes on our x-axis, Hygiene Day 2 goes on our y. And then if we want to add a trend line through our data, we could say do a total. Under chart appearance, if you wanted to change the color that your dots show up as, that's where you would do that. But I'm going to keep it as a default of blue, so I'll click OK. And then I get a graph that looks something like this. I'm going to relabel this by output as day 1 versus day 2 all, so it's easier to find. If I double click in my graph, I can change various chart elements. So if I wanted to change the title or my X or Y axes labels, I could do that. For my linear trend line, if I right click on this and go to, oh no, it changed elements. If I right click on that and go to Properties window, I can attach an equation of the line to this trend line here, so we can click Apply, and then you'll see it pops up there. For lines, if you wanted to change the color, the weight, or the style, that's where you would do that in there, but I think everything is okay as is. Okay, if you wanted your trend line to stand out more, you could change the color, but as long as it's there with the equation and your r-squared value are listed, you're fine. So I'm going to click Exit, and that would be our first graph. For the second graph, we want to basically plot the same data, but instead of having just one color of dot, we're going to have 2 colors of dots. One would represent males, the other one would represent females. So we'll go back to Graphs, Chart Builder. This set color box is basically our legend area. So we could identify 2 different colors in our graph by dragging sex into that box. Instead of doing a linear trend line through all of our data, maybe I want to look at the difference between males and females in their r-squared values, as well as what the trend line might look like, or the equation of a line might look like for each sex. So I could change this to subgroups. Under chart appearance, category 1 will be the variable that shows up first in this list. So males are going to be listed as blue, which is kind of the default color. For category 2, maybe you want females to be green or purple or orange or whatever. So you can choose your colors there. Click OK. And then our second graph populates. And I just realized I forgot to change something. So I'm going to go back to Chart Builder. Oops. And instead of Hygiene Day 2, the instructions wanted us to plot Hygiene Day 1 against Hygiene Day 3. So, just kidding. There we go. If I double click on my graph, I can change my various chart elements. So, if I click on my trend lines, right click and go to Properties window, I can attach the equations of the lines to their respective best fit. Again, you can change the color of those if you want to. Up in this area, let's say we wanted our text style to be different, right? So you could change text style or color. I think it's probably cleaner if we just keep all of those to black. But this is kind of nice because now we could see the difference in covariance between males and females. So approximately 12% of the variability we see in Hygiene Day 1 values is due to the relationship or the variance we see in Hygiene Day 3 values for males. For females, that covariance value goes up. So it could be argued that Hygiene Day 1 values are somewhat, or maybe we could flip that statement and say Hygiene Day 3 values are somewhat dependent on Hygiene Day 1 values more than what we would see in males. Because the variability we see in female Hygiene Day 1 values could be more explained by the variance we see in Hygiene Day 3 or vice versa. Okay, cool. And then before I move too far, I'm going to label this Day 1 versus Day 3, and then both, because both males and females are in the same graph. The final chart that we are making is where we want males and females in separate graphs. And the way that we do this is we could turn split file back on, comparing groups by sex. Then go to Graphs, Legacy Dialogues, Scatter Dot. Just a simple scatter is fine. And then we can define our X and Y variables accordingly. Press OK. And then we get our males and females scatter plots separated out. So this one, I'll put Day 1 versus Day 3, I don't know, separate. If I double click in my graph, I can edit my chart title so that it is Hygiene Day 1 versus Hygiene Day 3 for males. In the chart area, I can add a trend line, attach the label to the line. I can change the color. Sure, we'll make it red. Okay, and then we can see my R-squared value is listed up at the top. For my females, I could do the same thing where I specify that we're looking at Hygiene Day 1 versus Hygiene Day 2, or Day 3, sorry, sex being females. If I wanted this to be consistent with previous graphs, I could change my fill color to green. Maybe let's have a darker border so that they stand out better. Okay, I can also add a trend line. Maybe I want my line to be red again. Okay, so you can change various elements similar to our previous examples. But that would be how you could generate 3 different scatter plots, 3 different ways. Technically we have 4 scatter plots, but different ways that you can insert scatter plots based on various criteria that you want to plot. Alright, so that concludes our practice 2 video. And now you should have all the materials you need to take the activity practice 4 quiz.